Good morning, students. This is a modern periodic table I have taken from the IUPAC website. You also can download the periodic table. This periodic table, it is the latest periodic table given by the IUPAC. IUPAC, you know, this is the International Union of Pure and Applied Chemistry. So this is an authentic periodic table. Many periodic table you can get from Google, but this is the latest and authentic periodic table from the IUPAC website. So we are discussing about this group number 13 to group number 18. This is a group only 16, 17 and 18. So this is group number 16, 17 and 18, oxygen family, and this is a halogen family, and this is a group 18 elements, helium, neon, all the inert gases. Now the inert word is not, we are not using the word inert because these gases can react. This xenon can form many compounds. So these are rare gases because their percentage is rare in the atmosphere. That's why these are called as rare gases, remember. So this boron, carbon and nitrogen part is discussed in 11th standard. So this group number 13 to group number 18, this entire block is called as P block. See, there are 1, 2, 3, 4, 5, 6. 6 groups are there. As the capacity of p orbital is 6 electron, maximum 6 electron can be accommodated. So valence electron in this boron, carbon, nitrogen, oxygen, halogens and zero group elements enters in p orbital. That's why these elements are called as p block elements. So this is another periodic table I have taken from your textbook also, but this is a clearly we can see here group number 13, 14, 15, 16, 17 and 18. So again, I will send the notes of group, this elements of groups 16, 17, 18 after this lecture. After finishing the lecture, I will share the notes of this chapter. So remember this group 13 to 18, this is a P block, and this group number 1 and group number 2, this is S block. And this 3 to 12, this is a D block because in this S block elements, last electron enters in S subshell. This group number 13 to group number 12, the last electron enters in penultimate shell, which is not last shell. Before the last shell, there is a penultimate shell. So last electron enters in D orbital. That's why these elements are called as D block elements. And here, you can say this is a lanthanide series and this is actinide series. Actually, it is in 6 period. This is in 6th period and this is in 7th period actinide series. So these are lanthanide series 51 to 71. There are 14 elements and actinides 89 to 103. Again, there are 14 elements. So these lanthanides and actinides, they combinedly form the A block elements. So actually these A block elements are shown only below the periodic table. Actually these are included in the group number 3, 6th period. Lanthanides are group number 3, 6th period, and actinides are in group number 3 and 7th period. So in detail we will see the position of this lanthanides, actinides in chapter number 8 in detail. So again I am coming back to this occurrence of this group 8 elements. In this occurrence, 1 mark question will be asked on this ores. Gypsum, Epsom salt, this is baryte, galena, zinc blend and copper pyrites. These are the ores actually. So before the ores, we are discussing this group 16 elements. Group 16 elements contains first oxygen is the head of the family, which is having atomic number 8. Then sulfur, this is the symbol and this is atomic number is 16. Selenium, Se, atomic number is 34. Tellurium, T, it is the symbol, and 52 it is atomic number, and polonium, Po, 84. So I have prepared one sentence, how to remember this group 16 elements. Old, oxygen for old. Old, style, say, T, pew. That is, old stands for oxygen, style stands for sulfur, say for selenium, old style say T. T means tellurium, and PO means polonium. So we can remember this entire oxygen family. Old style say T, PO. This is oxygen family. Large number of metal ores are oxides and sulfides, remember. There are large number of metal ores are in the forms of oxides and sulfides. That's why these are also called as chalcogens family. Remember, chalcogens are also called as ore forming elements. Means many ores on the earth. These are made up of with oxides or sulfides. That's why these are called as also chalcogens. Chalcogens. The meaning is ore forming elements. Oxygen is the most abundant element on the earth. Oxygen uh, forms 20.95% by volume. By air, about 46.6% mass of earth crust. It is made up with oxygen. Then sulfur. I am coming to the sulfur. Sulfur forms. These values will be not asked for the examination. Remember. So don't worry about this value in oxygen, kitne percentage hai, then sulfur. These values will be not asked for the examination. This is not expected from the students. Remember these values. But this is expected to remember what are the ores of sulfates. So gypsum, it is having the formula is CaSO4.2H2. This is asked for exam. Write the formula of gypsum. This is expected from the students. Epsom salt. This is magnesium sulfate with 7 molecules of H2O, MgSO4 7H2O. The barite is a barium sulfate. And the sulfides such as galena, this is a lead ore, Pb, lead sulfate. This is a Pb, plumbum, and yes. So galena, this can be asked for exam. What is this galena? Galena, it is the ore of lead. Then zinc blend. Zinc blend, this is ore of zinc, copper pyrites, this is ore of copper, FeCO, Fe2. So that's why this is included in evaluative syllabus, because examiner can ask 1 mark question on this. Write the formula of the gypsum, write the formula of Epsom salt, write the formula of this barite, or barite means what. So for that purpose, this is kept for the examination, remember. Then this selenium and tellurium, these are the last elements out of this selenium, tellurium, and polonium. This polonium is a radioactive element, remember. Radioactive, this emits alpha, beta, and gamma radiations. Out of this selenium and tellurium, these are found as a metal selenides and tellurides in the sulfide ores. So occurrence, this is occurrence for oxygen family, and for the examination purpose, remember these molecular formulas and the names of the ores. Then I am coming to the group number 17 elements. Group number 17 elements, we are very familiar with these elements. These are called as halogen family. Halogens, this is a Greek word. Halo means salt, remember. See. Halo means salt and gene means bond. So the meaning of the halogens means salt producing elements. They produces salt. First one is fluorine, atomic number is 9. Then FClBri. This is a short form to remember. F fluorine, Cl chlorine, Br bromine, and I iodine. FClBri. So 9, 17, 35, and 53. These are the atomic numbers of fluorine, chlorine, bromine, and iodine, respectively. And this is astatine, but its chemistry is not very much known. Astatine atomic number is 85. So it is neglected actually from this group. We are considering this is a main elements. fluorine, bromine, and iodine. These are the four halogens, because this four elements chemistry is very much known to us. This astatine, this is the last member of the halogen family, which is radioactive and has half-life is only 8.1 hour. So its chemistry is not very much known, remember. So halogens are nothing but the salt producing elements. Halogens are very reactive. These are very reactive because of the high electronegativity, and they always wants one electron to complete its outermost shell. So that's why these are very reactive in nature. They are not found in free state. Always these are found in the combined state. Fluorine always occurs in soluble fluorides, like a fluorospar. This is as for example, remember, fluorospar having the formula CaF2. Then this is a cryolite. Cryolite having the formula Na3AlF6. Then fluorapite, 3Ca3PO4 twice CaF2. These are the ores of fluorines from where the fluorine is generated. And small quantities are present in soil, freshwater, plants, and bones, teeth of the animals. So this is occurrence of fluorine, where fluorine can be found. So fluorine always occur mainly as insoluble fluorides in fluorospar, then cryolite. So it is expected to remember the name and the formula. Remember, from the student point of view, it is expected to remember the formula and name of the fluorine ores and bromine, chlorine, where the chlorine is found. Seawater contains chlorides, bromides, and iodides. See, iodides of sodium, potassium, magnesium, and calcium. However, mainly NaCl mainly contains NaCl 2.5 percentage by mass. Then the deposits of dried up sea beds contain sodium chloride as and carnallite, KCl, MgCl2, 6H2. Marine life also contains iodine in their systems. So this is the occurrence of chlorine, bromine, and iodines. Mainly say chlorine, it is mainly found in NaCl, 2.5 percentage by mass. Then the deposits of dried up seabeds. Dried seabeds means seawater. When it is dried, it contains sodium chloride. Also the carnallite. Remember this name, carnallite. This is also included in the chapter coordination compound. So carnallite is the double salt which is made up of with salt of KCl and salt of this MgCl2. This is magnesium chloride and potassium chloride. These combinedly form double salt, and the name is carnallite. Remember, this can be asked for 1 mark examination. Write the formula of the carnallite, or they can give this name and what is the name of this. Write the name of the double salt. So the question will be like asked like this. They can give the name, or they can ask you to write the formula, or they can give the formula and we have to write the name of the salt. So vice versa questions can be asked for 1 mark. That's why it is kept. That's why it is kept for evaluative purpose, remember. And this is iodine. So remember, seaweeds means in case in sea there are different types of weeds contains 0.5 percentage of iodine, and this is a chili saltpeter contains up to 0.2 percentage of sodium iodate. So this is asked for examination many times. Remember this chili saltpeter. Uh, this is a occurrence from where the iodine can be generated. So it contains up to 0.2 percentage of sodium iodate. And astatine, I already discussed this. This is radioactive, and its chemistry is not very much known. So out of this occurrence of group 16, occurrence of group 17, and occurrence of, I am coming to the group 18, only 1 mark question will be asked. So today make a chart of this occurrence, from where the fluorine can be generated, from where the chlorine can be generated, iodines can be generated. Write the ores of iodine, chlorine, fluorine. Make a chart and paste it in your study room. Now we are discussing with the noble gases. Noble gases, or it is IUPAC name is group 18 elements. These are outermost shell is already completed. Helium atomic number is 2, neon atomic number is 10, argon atomic number is 18, krypton 36, xenon 54, and this radon is 86. All these helium, neon, argon, krypton, xenon, radon, these are constitute with the group 18 elements. All these noble gases except radon occurs in atmosphere, because the radon can be prepared with this radioactive decay. From this radon is generated. All the noble gases occurs in atmosphere except this radon. Only radon it is obtained from this radioactive decay. This decay is shown here, radium. With the decay of this radium, when it is decayed, we get radon and helium. So their abundance in dry air is very, very less. That's why these are also called as rare gases. Nearly equal to the 1% of volume out of this helium, neon, argon, krypton, xenon, radon. This argon is the major constituent. The main commercial source of helium is a natural gas. Helium and neon are found in minerals of radioactive origin like this. Remember the names only. This pitch blende, monazite, cleavate. These names can be asked for examination, remember. This pitch blende, monazite, cleavate, these are the from where we can generate helium and neon. And this xenon and radon are the very, very rarest elements of the group. So these questions can be asked for 1 mark. Xenon and radon are the rare elements, and from where the radon can be generated. So I am not discussing in detail because we have to discuss this electronic configuration. Wait for 1 minute. Yes. So this is a electronic configuration is given group number 16, 17, and 18. Combinedly, it is given oxygen family. The names of the elements of oxygen family is given here: oxygen, sulfur, selenium, tellurium, and polonium. Old style say TPU. This shortcut I have given: old style say TPU. This is a condensed electronic configuration. This is also called as electronic configuration with respect to inert gases. Inert gases are kept in brackets. So helium, you know, atomic number is 2. Neon is atomic number is 10. Then krypton, argon atomic number is 18. Then krypton is atomic number 36, and xenon is atomic number 54. So this is a condensed electronic configuration. We can see clearly. This is a general electronic configuration NS2. NP4. So this is 2s2, 3s2, 4s2, 5s2, and 6s2. So the general electronic configuration of this oxygen family is NS2, NP4. It is shown here. NS2, NP4. So clearly we can see in this table. This is a NS2 and NP4. So 4 electrons are there in the outermost p orbital. So NS2 NP4, this is NS2 NP5, and this is NS2 NP6. NS2 NP6, only this is exceptional. Helium is exceptional, it is only NS2. So the general electronic configuration of oxygen family is NS2 NP4, halogens is NS2 NP5, and the noble gases is NH2NP6 except helium. Helium is NH2. So this is a general electronic configuration. For 1 mark, it may be asked for examination. Write the electronic configuration of iodine, bromine, or chlorine. So we have to remember the atomic numbers. They will not give the atomic numbers of this fluorine, chlorine, bromine, and iodine. So we have to remember these atomic numbers and atomic numbers of this all the elements. So today, write this table at your home. I will share these notes after finishing this lecture. Also, you can take the printout of this page and we can paste in your study room. So this is a general electronic configuration. Understand? I think you understand this is a general electronic configuration. This noble gases, outermost shell is already completed. See, 1s2 means the capacity of S orbital is completed, the capacity of P6 is completed. That's why these are chemically inert. They do not want to give the electrons, or they do not want to accept the electrons. That's why the name noble gases is given. Then I am coming to the atomic properties combinedly of group 16, 17, 18 elements. Combinedly, I will discuss with this atomic and ionic radii. So I am not explain again what is mean by atomic and ionic radii, what is ionization in energy, what is electronegativity, because in 11th standard we detailed explained. In detail I explained this ionic radii, atomic radii, what is mean by ionization energy, or it is also called the ionization enthalpy, then electronegativity, electron gain enthalpy. All these periodic trends are in detailed we discuss in 11th standard. So directly I am coming to the trends. What is happening with this atomic and ionic radii? You know, always in the periodic table we can see, I am showing the periodic table to you. See this in this periodic table, oxygen, from oxygen to this polonium, atomic and ionic size increases. In case of this halogen family also, atomic size and ionic size increases from top to bottom. That is fluorine to astatine. In this group, oxygen to polonium. In this group, helium to radon. Atomic size increases as atomic number increases. Remember. So again, I am coming back here. So atomic and ionic radii increases down the group. So this is increases because the number of shells are increasing. We can see here number of shells are increasing. Here is shell number is 2p4. Here is 3 shells are increasing. So we can see here second shell, third shell, then fourth shell, fifth shell, sixth shell. In oxygen family also, in halogen family also, we can see in the noble gas family also, as we move from top to bottom, the shells are increasing. As the shells are increasing, atomic size is increasing. As the atomic size is increasing, the electrons goes away from the nucleus. As the electron goes away from the nucleus, we can easily remove it. So the ionization energy will be decreases. Means ionization energy is the amount of energy required to remove most loosely bound electron from the isolated gaseous state. This is the definition of ionization energy. In 11th standard, we already discussed in detail. So as the electron go away from the nucleus, in case of this polonium, we can easily remove the electron. From this astatine, we can easily remove the electron. From this iodine also, we can easily remove electrons as compared to this fluorine. This fluorine electrons are closely to the nucleus, so the ionization energy values will be very high. We can see this. This is a table. We can see this is a table of group 16 elements, and this is a table of group 17 elements. See the atomic radius and ionic radius. We are comparing this. ionization energy. See, the ionization energy of oxygen is 1314 kilojoule per mole, and see the ionization energy of polonium is 813. Means amount of energy required to remove the electron from this polonium is very less, because electrons are away from the nucleus, and in this oxygen electrons are nearer to the nucleus. So this is very difficult to break. It is difficult to remove the electron from this outermost shell. We can easily remove the electron. So if you compare this ionization energy values of this fluorine and iodine, see, iodine is only having the value 1008 kilojoule per mole. Means this amount of energy is less than the fluorine, because the atomic size of this fluorine is very less, and atomic size of iodine is very high. Means electron is away from the nucleus. So I think this properties, no any question will be asked from this table, remember. So these tables are only for understanding the trends. Atomic number, how atomic number is increases, how the atomic mass increases, how the atomic radius is increasing, how the ionic radius is increasing, ionization values decreasing, and see the electronegativity, oxygen having the higher electronegativity values are also decreasing. So no any value will be asked for the examination. So these tables are actually deleted, non-evaluative. These tables are non-evaluative, means no any question will be asked from this table, but for understanding the trends, I have given these tables. So atomic and ionic radii increases from top to bottom, and across the period, what will happen? The atomic and ionic radii decreases. This also I will explain. Again, I am coming to the periodic table. See. So from top to bottom, atomic size will be increases, and from the in the period. So in the period, what will happen? The electron is added in the same shell. See, in case of boron, there are 5 electrons. In case of carbon, there are 6 electrons. In nitrogen, there are 7 electrons. Oxygen, there are 8 electrons. In fluorine, there are 9 electrons. So what will happen across the period as we move from this boron to the fluorine? Electrons are added in the same shell. So what is the effect of this electrons are added in the same shell? Effective nuclear charge will be increases. As the effective nuclear charge on the nucleus will increase, it will pulls the electron towards itself. So atomic size will decrease across the period. Atomic size will be decreases across the period, and in a group from top to bottom, atomic size increases. Remember. So again, I am coming to the trends. So across the period, atomic and ionic CDIs are decreasing because Z effective is a effective nuclear charge. It is increases, and why this is increases? Because electrons are added in the same shell. Group 17 elements have the smallest atomic radii in their respective periods. Now I am coming to the ionization energy. This is also I explained. Ionization energy means nothing but amount of energy required to remove most loosely bound electrons. As atomic number increases, this ionization energy decreases, opposite. And across the period, ionization energy increases because electrons are coming closer to the nucleus. This ionization energy is exactly opposite to the ionic radii, remember. As ionic radii increases from top to bottom, this will be decreased. So ionic and atomic and ionic radii decreases from the period, so the ionization energy will be increased. So this atomic and ionic radii and this ionization energy is exactly opposite, remember. So for the examination, this can be asked for 1 mark. Atomic radii and ionic radii can be asked for 1 mark. Then ionization energy can be asked for 1 mark. No any values will be asked for the examination. These are the values of group 18 elements. Now I am coming to the electronegativity. Electronegativity, the definition already explained in 11th standard. But once again, I will explain what is meant by electronegativity. Electronegativity means it is the ability of the atom to attract shared pair of electron towards itself. So this attraction ability, it is found, we can see the electronegativity values here of any group. See the group number 16. Yes, electronegativity values are given here. See, the electronegativity of oxygen is 3.50 and electronegative value of this polonium we can see 1.76. So the electronegativity values decreases from top to bottom. We can see here in this group number 17 also. Fluorine having the electronegativity value 4 and iodine we will compare only these 1, 2, 3, 4 elements. So fluorine having higher electronegativity and iodine has the less electronegativity. Means this first member can attract shear pair of electron towards itself. So there is maximum attraction of the nucleus and the outermost electron, remember, because these are closer to the nucleus, and this is happening due to the less atomic size is very less. In case of oxygen is more electronegative, fluorine is more electronegative, and in case of nitrogen family, nitrogen is more electronegative. So oxygen has the highest electronegativity in the oxygen family, and in case of halogens, fluorine having the highest electronegativity. Fluorine is the most electronegative element in the periodic table. Remember, this is as per examination. Which is the most electronegative element in the periodic table? Such type of questions are asked for 1 mark. So that's why it is shown in bold type. That's why it is shown in bold type. Then I am coming to the electron gain enthalpy values. Electron gain enthalpy values means when the electron is gained, the amount of energy released. Amount of energy released when electrons are gained. So in group number 16, 17, electron gain enthalpy values becomes less negative down the group. We can compare this electron gain enthalpy values. So electron gain enthalpy values of group 16 elements. See, these are the electron gain enthalpy values becomes oxygen having minus 141, then selenium having 200, then 195, 190, 194. So it is actually decreases from less negative. All the values are negative. This is minus 141, minus 200, minus 195, minus 190, 194. But this sulfur is showing minus 200 value because of this small size of oxygen, remember. This is also mentioned here. In case of group 16, oxygen has less negative electron gain enthalpy than the sulfur because of its small atomic size. Same it is applicable for the fluorine also. Fluorine has less negative electron gain enthalpy value than the chlorine. See here. See the electron gain enthalpy value of fluorine is minus 333 and that of chlorine is 349. This is smaller because of small size. Due to the small size, this is happening. In case of group 18 elements, they are having no tendency to accept the electrons because of stable electronic configuration NS2 and P6. They are having the large positive electron gain enthalpy values. Remember, in the entire periodic table, only the group 18 elements having the positive electron gain enthalpy values, and except these group 18 elements, all the periodic table, in all the groups, we can find the electron gain enthalpy values are negative. So we completed the trends of atomic size, ionic radii, then ionization energy, then electronegativity, electron gain enthalpy values. Now we will discuss some problems. Same to same problems cannot be asked for the board examination, but they can make a change in the problems. But type of problems will be same. That's why I am discussing the problems, because many students don't know the problems will be asked for the examination or not. Same type of problems will be asked, but only the questions will be changed. Suppose, for example, here is given problem number 7.1. Elements of group 16 generally show lower values of first ionization energy compared to the elements of the corresponding periods of group 15. Why? So they can change the question. Instead of group 16, they can give group number 17 also. So first we will understand what is this question is given, what is the problem is given. Elements of group 16 means group 16 is oxygen family, generally shows lower values of first ionization energy. Means first ionization energy means first, if the first electron is removed, it is called as first ionization energy. The amount of energy required to remove the first electron, it is called as first ionization energy. Then amount of energy required to remove the second electron, it is called as second ionization energy. Then amount of energy required to remove the third electron, it is called as third ionization energy. So these are the first, second and third ionization energies. But what is the question? The values of first ionization energy of group 16s are lower as compared to the elements of corresponding period of group 15. Why? So the answer is given here. In case of group 15 is nitrogen family. I want to discuss this numerical or this problem because the outermost electronic configuration or general electronic configuration of group 15 elements is NS2NP3. We can see clearly there are only 3 electrons in the p orbital, and this is completely half filled because the capacity of p is 6 electrons. In case of group 15 it is a 3. So due to this half filled p orbitals, group 15 elements got extra stability. So group 15 elements are extra stable. Extra stability, it is due to the half filled p orbitals, and due to this more amount of energy is required to remove the electrons from this. So group 15 elements having the higher values of ionization energy than the group 16 elements, because in case of group 16 elements, the outermost electronic configuration is NS2NP4. Here in case of p orbital there are 4 electrons. It is not half filled. Half filled means if the capacity of p orbital is 6 electrons, half filled means 3 electrons are there. So this is happening only in case of group 15 elements. That's why the ionization energy values of group 15s are high than the ionization energy values of group 16. So this is the reason of half filled. Then I am coming to the problem number 7.2. The values of first ionization enthalpy of sulfur and chlorine are 1000 kilojoule, and that of chlorine is 1256 kilojoule respectively. Explain the observed trend. So the elements sulfur and chlorine belongs to the second period of the periodic table. Across the period, what will happen across the period? The effective nuclear charge is increases, so the atomic size will be decreases. So amount of energy required to remove the electron from the valence shell for the chlorine will be more than the sulfur. If we can see the periodic table, again I will show the periodic table. Only 1 minute is remaining. See this chlorine and sulfur. So you know